So today's session is all about AWS Discovery Day. And the name is saying it all, right? Discovery Day means we are trying to discover AWS. So we will be talking about some of the basics, right? So this is not an advanced level training. We are trying to introduce you into what is AWS, what are they doing, what are the different services out there. So we will start by looking at introduction to the cloud, right? What is the cloud? Why do I need it in the first place? You know what? I have been dealing with on-premises deployments for over 10 years, and I'm very happy with that. So why all of a sudden will I go to the cloud? What will make customers move from having applications with networking, with DNS servers, and all of those stuff we learned over the years and go to the cloud? What are the benefits out there? Once we set the ground and we have a good understanding, which I'm pretty sure that most of you have this background, then we will start to talk about the core services that you can use if you decided to choose AWS Cloud. So what if you want to do virtual machines on the cloud? What is the name of the service on AWS that allow you to do that? What if I want to do something like container on the cloud? What is the name of the service? What if I want to have security and compliance? Because, hey, you know what? I live in the Middle East, and security and compliance is a very big question mark. And this is probably the first thing when you talk with any customer. No, I'm not going to go to the cloud because I'm worried about encryption. I'm worried about data locality. I'm worried about compliance. I do have regulations in my country that tells me that I'm not supposed to put my data on public cloud. So we have really something for everyone, right? If you're a system admin, we'll talk about some services related to that, compute. If you are a network engineer and you have been dealing with, networking throughout your entire life, well, we'll have a section to look into that. If you are a security guy coming from a firewall background and access list and allowing and denying, that's what you do on a daily basis, we have a section for you as well. Even if you are a developer coming from development backgrounds, we do have as well a section. Due to also the time constraints of our session, we will be having the Q&A at the end of the session. So we do have a dedicated section at the end of our webinar. Feel free, shoot any questions you want, whether it's related to the presentation or it's not related. I can also guide you to the right resources and documentation to dig further on top of that. Let me tell you something as well. I think that's a good starting point before I go into the technical stuff is let's talk about the AWS certifications for a minute here, right? So where exactly are we in terms of AWS? If you go to aws.amazon.com/certifications and you go all the way down, you'll see that AWS is categorizing their certificates into 4 different levels: foundation, associate, professional, and specialty. Foundational, this is like one-day training, giving you most of the fundamentals that you need about AWS. Once you are done with that, then you go to the associate levels. We do have the Solution Architect Associate certificate, which you can get by attending and taking the exam, which is the Architecting on AWS, which is the training that is going to run next. You also have some other certificates, such as developer, SysOps, data engineer, depends on what kind of a specialization you want to go into. However, what we really recommend before you jump to any one of those certificates, go through the Cloud Practitioner and the Solution Architect. The Cloud Practitioner, by the way, you can get this as an instructor-led, or you can also get it for free. AWS is providing this as an on-demand. And what we are doing today is kind of setting the foundation so you have a starting point so you can go to the cloud practitioner, right? So this webinar doesn't actually represent any certifications out there. We're just trying to draw the baseline or the starting point for you. The reason why you see so many certifications out there, because AWS, they have so many services. They have more than 200 services. So we couldn't really cover all the services in like one or two trainings. That's why you have different specialty and different certifications. You do have associate level and professional level certificates as well. And then once you're done with those, now you can be specialized into networking, data analytics, databases, security, where you can then learn about more info and more services related to that specialty, right? So this is just an overview. So where we are actually here. We are before the cloud practitioner in that case. Okay, so moving to the presentation. So the first question probably you might ask yourself is, why cloud computing? Very simple question. Why would I go put my resources on the cloud? Well, to answer this question, we have to take a trip back in time when we want to deploy application on premises. When you wanted to deploy an application within your data center, you had to think about a few stuff, such as what are the amount of computing resources that I need? Do I need one server, two servers, three servers? What is the amount of CPU and RAM? Think about Amazon, right? Amazon.com. They have their Amazon Prime Day or Black Friday that happens every year, where you have a lot of visitors going through their web portal. How do they scale that? How do they expect how many users could be visiting their portal on that day? How can they make sure they have enough CPU, RAM, storage to fit all of those requests coming on that day? Those are the common challenges that you see with on-premises, right? The prediction. How many resources do I have? And then I'm afraid that sometime I don't meet the resources because I under provisioned. I bought less servers than what I need. And that would be a problem. The other problem is maybe I bought too many servers, which I don't need all of them. So I exceeded what I actually wanted. So that was a waste of money because most of those resources will stay idle. And that's why the cloud is highlighting those challenges. The cloud is all about having what we call it on-demand delivery of IT resources and application. On-demand in a simple way means if you need a virtual machine now, you can go ahead and create it. When you create the virtual machine, you pay for it. When you stop your virtual machine or you delete it, you stop paying for it. As if like rather than you having to build a data center, get a server, put your virtual machine on top of the server and maintain the server, it's like as if you are renting someone else's server. And you only pay when you use that server. If I don't need it, I delete my virtual machines and I stop paying for it. That's why we call it's an on-demand. It follows something called pay as you go. When I need the resources, I create them. I don't need them, I delete them, and I stop paying for them. As a result of that, you don't need to make large upfront investments in hardware. You don't need to spend a lot of time on managing that hardware. Instead, you can provision exactly the right type and the right size of computing resources that you need to power maybe your newest idea or operate your new IT department. So What can I get from the cloud? Well, there are multiple services that we offer you. Just to name a few, you can get servers. You can get them in the form of virtual machines. You can get them in the form of containers. You can get them in the form of something called serverless, which is just allowing you to launch a code. Cloud computing allow you to have access to storage. So maybe you say that, hey, I want to have something like block level storage, or I want to have a file level storage on the cloud. Or maybe what I want is I want to create a database, something such as a SQL database or a relational database or a non-relational database. I want to run MySQL, but I don't want to take care of the hardware where this MySQL database is installed. As a result of this, when you go and approach the cloud service provider, such as AWS, what they can do is they can own and maintain the hardware, the network components, and even the hypervisor where those applications, storage, databases are going to be hosted. With all of that, they give you a very nice and easy interface where you can fill in the details with what you want. And then they can bring those IT resources for you up and running within a few seconds. This is what we are going to refer later on as what we call it your AWS console. If you want to create any resource in AWS, you come to the console, you go to the right service, you say that create new, right? And then you fill in the details and then you click on finish. And voila, within a few seconds, your IT resource that you need, like a virtual machine, is up and running. We also treat these resources as temporary and disposable. And what I mean by saying that is, if I need a virtual machine now, I can come to the console, create the virtual machine. If I don't need it, I can go ahead and simply delete that virtual machine. When you compare this to what we used to do on premises, there is such a huge difference. Because sometimes to create a virtual machine on premises, we had some constraints. You had to take an approval. You needed to look into the network. You needed to look into the resources on the servers. Do I have enough RAM? Do I have enough memory? Okay, let me go ahead and find the right ESXi server, which have the right components and the available resources. Then I go to the network. Okay, let me make sure the VLAN is defined. Then I go to the storage and then I say, oh, let's make sure I have available volumes on NetApp or Dell or whatever I'm using at the back end. So what the cloud is trying to do is it's trying to give you so much power available at your hand, and all of that power and automation, we put a front end, which is a super easy and nice console, which is user-friendly that you can use, freeing you from the inflexibility and the constraints of a usual on-premises fixed IT infrastructure. So, integrating a cloud strategy can mean different things to different organizations. Some organizations, they might go with all cloud services. That means you don't use anything at all on premises, right? You design, you build your applications right away into the cloud. Fair enough. The other option is you might decide to go with something called hybrid deployment. In a hybrid deployment, you can mix and match, maybe due to compliance, or could be due to some legacy applications. They need to remain on premises. Or could be you have a government regulations that require your business to keep certain records on premises. But then you're using this hand in hand with the cloud. A common approach here would be, for example, you put your application on the cloud, such as your virtual machines, but then all the storage remain on premises. So this is what we call it hybrid cloud. When you have users, for example, visiting your website, they go to the cloud, all the data generated is actually saved on premises, so you can have full control over it. The third deployment is to have an on-premises deployment. While this model is very similar to IT infrastructure, we still can also use this as a cloud. Someone's like, how come? Well, here's the tricky part. I can design everything from on-premises by buying my own servers or my own network, etc., etc. But also, even the cloud provider, they can give you servers and racks that you can install on-premises. For example, AWS, they have something called Outpost, which is a server that you actually get and install it on premises, but you can manage it using the AWS tools, using the AWS console. So all the features like virtual machines and containers and stuff like that, you can still leverage all the AWS features, but on premises. So those are the three deployment models, either full cloud or hybrid in between or on premises. And this solely goes back to the application and also the compliance and regulations required by the customer. Looking into the benefits of AWS, have you ever wondered why so many organizations are moving toward the cloud services? Well, that's because there are many advantages to the cloud computing in general. Moving to AWS cloud is like having a virtual office. It gives you the increased flexibility of connecting your business anywhere at any time. This is really the goal behind it. And there are four main factors that impact that flexibility: agility, elasticity, cost savings, and rapid deployments. Let's try to explore each one of them just to point out more details about it. Starting with agility first. This is simply the organization ability to quickly adapt in response in the changing opportunities and demands. Think about it this way. If I have a server, right? And that server is on premises. On that server, I created multiple virtual machines, right? Later on, I have more demand on the application. So I need to create more resources. I need more virtual machines. One of the primary challenges you might run into is you don't have enough space anymore, right? You don't have enough window anymore in that server to add an extra instance of your application. That's why before you scale, for example, you need to consider that, okay, maybe I need to have another server to be there just to make sure in the future, if I need more resources, I have a window to scale up or scale out. Well, you don't need to think about that on the cloud because something like AWS, they already have data center, plenty of data centers, in fact, distributed among the entire globe, organized into something called regions. And you can create your resources, scale them up, scale them down only within a few clicks. So that means you can reduce the time to make those resources available to your developers. You don't need to worry about, do I have enough resources or not? And as a result, you can experiment and innovate more easily and more frequently because now you have the flexibility to develop something new, test it. If it works, fair enough, I can bring it online. If it doesn't, let me remove it and I will stop paying for that. Having that agility, creating resources whenever you want, deleting them whenever you want, is all contributing to the same goal. Think about applications such as artificial intelligence. which happening nowadays. That requires so much testing and so much resources for learning and stuff like that. How can we accommodate all of those resources on the fly? Cloud can get this done for you. Second one is elasticity. Elasticity is another powerful force in cloud computing. It is the idea of being able to scale up or down while only paying for the actual resources which you used. So you need today one virtual machine. Fair enough. Tomorrow, you might need thousands of virtual machines. You can do that on the cloud. Whether you need the virtual machine for only a few hours, or maybe you need it 24/7, you want it always to be up and running, the cloud can get this done for you. So maybe even what I want to do is I want to be able to distribute my workloads across multiple resources. Think about an example where Amazon.com, they have a marketing promotion. And in an unexpected way, it became very popular. So there are so many people visiting our website right now. We want to avoid a site outage. What should I do? I should be able to add more resources on the fly. This is what we call it elasticity. I want to be able to deploy my application in a fault tolerance way. Fault tolerant, think about it this way, right? Think about natural disasters. Usually people will have two data centers, right? Data center 1 and data center 2. And those data centers probably they are geographically isolated from each other. They are far enough to make sure if I lost one data center, I had a power failure, or God forbid, something happened to data center 1, then data center 2 remains up and running and functional, and I can redirect the traffic. Well, this is what usually people want. But then to build that, it is not cost friendly, right? Because now you have two data centers, you have two spaces which you need to rent, you need to manage the networking between them. For each data center, you have a power, you have cooling, you have an entire team who is managing each data center and making sure it's up and running. So eventually, you can have two instances of your application running on data center 1 and 2. If I lost one, the other one provide me with availability. Well, you can do that on premises, and that's how you do it. The cloud is designed in a way to provide this to you in a native manner. We can, when you actually go ahead and deploy something on the cloud, you can choose multiple availability zones, as if like you're saying, I want to have two instances of my application, need one of them in data center 1 and another one in data center 2. All of that with a few clicks, excluding the idea of you having to configure the networking part and the applications and the data center interconnectivity and all of that. Last but not least is the cost savings. Someone is like, how are you saving costs when you're moving to the cloud? Well, what you're really doing is you are eliminating what we call it the CapEx, or the capital expenses. When you're building your own data center, you are paying for the power. You are paying for the cooling system inside the data center. You are paying for the space because, hey, maybe that data center is not yours. Maybe you're actually renting the building. You are paying for the entire team who's managing this, right? All of that are expenses. And hey, you know what? Maybe inside that data center, you have multiple servers. Maybe you're not using all of them. Initially, you bought 100 servers, but you don't really need all of that, because what you did is, right, going back to our first slide, what you did is you over-provisioned your data center. I bought so many resources because I'm trying to protect myself. If one day I have a peak, I have a spike in traffic, I have enough servers to accommodate that. But in fact, most of those could remain idle. That's a waste of money. AWS or cloud in general, right? It can save you money because you only pay for what you use. You don't need to build a data center. You don't need to pay for power, cooling, or space. You only need the team probably who will manage, right? Go to the AWS and create the resources and doing all of that. At the back end, AWS is taking care of all the hardware, the maintenance, the upkeeping of the data center and its equipment. On top of that as well, your company is reducing all the energy costs, achieving some sustainability because you're also reducing the carbon footprint that was going to be generated by your data center. The other thing, there is usually another term that we use when we talk about cost savings, which is economies of a scale. And what that means is, think about it this way. If I'm living in an apartment, right, and I'm renting this apartment, that means I'm paying the full rent, right? So if the rent is like something like $100, I'm paying the entire $100. If later on I invited someone, one of my friends, to come and live with me in the same apartment, and we decided to split the rent, well, that's good. So now I'm actually saving 50%, right? I'm only paying 50% of what I used to pay before. Now imagine I bring so many of my friends and we live together. And as bad as this might sound, right? But from cost point of view, this is really good for me because I'm saving money, right? Now think about it from this perspective on the cloud. Something or some cloud provider such as AWS, they have a server in their data center. You take one virtual machine, I take another virtual machine, a third customer use another virtual machine, and so on. So each customer have their own virtual machine, and AWS is sharing that server among all of those customers. The result of that is that I pay less amount of money to host my virtual machine on AWS, because now the cost of running the server is shared among all the customers who are using this server with me right now. So now what that means is the more customers who actually use the cloud, the cheaper the cloud services become, because you are sharing the cost among with other people who are hosting their services on the cloud. And this is what they call it, massive economies of a scale. Imagine if AWS started in one country, and right now they have more than 30 regions in 30 different countries in different continents with millions of customers. And that's why you can get a virtual machine running on AWS and you pay like, I don't know, 10 cents maybe per hour, if even not less than that. This is how you can achieve cost savings on cloud. Of course, on top of all of that, the fourth benefit of AWS is the rapid deployment. Think about it in a way that maybe you are working within the AI industry, and there are new applications that come in, or maybe there are new algorithms that are being invented. What you need to do is, if you want to run this algorithm or this new application, you got to make sure that on premises you have the right resource to run this application. Maybe if the application requires a certain amount of GPU, do you have a server with that amount of GPU? That's the question, right? With the cloud, you don't need to think about that, because every time there is a new feature out there, a new type of hardware resources that maybe Dell has invented or NVIDIA has come out with, AWS take that, they deploy it in the data center, and they offer it to you. And that allows you to rapidly get new features help avoid downtime during the application deployment, avoiding all the complexity of the infrastructure. On top of all of that, what if today my customers are in UAE, right? I'm living in the UAE and Dubai. So today my customers are in Dubai. All of a sudden, my Amazon.com website, my e-commerce website became popular. So now I have people coming from the US trying to connect it to my application. The problem is people coming from the US, they will experience delays. This is due to the fact that the application is far from them. One of the benefits of using a cloud provider is that you can choose to deploy your resources in any one of the regions supported by that cloud provider. We call it, or we refer to that as the AWS Global Infrastructure. As we speak now, AWS exists in more than 30 different regions. That means when I go to the AWS console and I say I want to deploy a virtual machine, I have a nice drop-down list here on the top right corner where I can choose where I want this virtual machine. Consistent experience, right? It's exactly the same user interface. You just choose where you want your resource to be. What is the benefit of that? Well, guess what? You can put your applications as close as possible to the customers, making sure that you avoid any delays or latency or a bad user experience. Not only that, you can literally go global in minutes. You don't need to think about, I need to deploy another data center, maybe in Paris, because right now I do have a customers over there. Having that, flexibility at your fingertip, it's just the limit is the sky when you think about it, right? I can be anywhere at any time. I can easily provide high availability for my application. And right now, as we speak, AWS is the leader in the Gartner Magic Quadrant for cloud infrastructure as a service. They got this for like more than 9 years in a row by now. And AWS have the largest, out of all the cloud providers over there, they have the largest number of regions, which means that they have the largest existence among the rest of the cloud providers. And that's why it's quite famous, and that's why AWS is considered to be one of the best cloud providers out there, because it just fits most of the scenarios, right? If your customer in the US, good, I can put your applications there. If your customer is in UAE, I can put my applications there, right? So having that global scale simply allow it or make it the go-to cloud provider for many customers due to the existence in different countries. So if I want to host my resources in AWS, what are the components that I need to know about? And for that, let me just quickly whiteboard this for a minute before we get into the details. So the first thing that you need to pick when you are creating resources on AWS, you need to pick something called a region. As a simple way, you can think of the region as a country. It doesn't have to be a country, but just think about it as if this is a country. This is something like the US. So the region will simply represent in which part of the globe you want to deploy your resources. Fair enough. Does AWS have one region? No. As we speak right now, there is actually a portal called AWS Infrastructure. Let me also go ahead and show you this. AWS Global Infrastructure. No, not this. You can just look this up, and that's the portal. And this is where it will tell you how many regions they have. Currently, as we speak now, there are 32 regions that has been launched by AWS. Okay, so can I pick any region? And the answer is yes. You can choose any one of those regions. So the beginning, you pick a region. Okay. What if I have different applications in different regions? Like maybe I choose the US region, and then I also have some applications hosted maybe somewhere in Europe. Are those regions connected together? And the answer is yes. So by default, all the AWS regions are connected together using private fiber links, which are being managed by AWS. And those are high-speed fiber links that goes maybe underseas between the continents due to the fact that AWS is trying to achieve privacy. So they don't want to use public links, right, to connect between the regions, even though you can. But the default is if you have resources in different regions and you want them to communicate, you can do that. Why would you use different regions? Well, latency. Today, I started my application in the US. So I created my virtual machine in the US. Tomorrow, I have some customers in Europe. So maybe I can replicate my architecture, replicate my design, and put it in Europe. So it can be, close to the customers. Different regions also comes with a different cost. Hosting services in the US could cost different than hosting the services in Europe. This is due to the fact that, doing business in different parts of the world can actually cost different amount of money. When you say, I want to host my resources in the US, inside the region itself, we have something called an availability zone. Okay, so probably what you want to do is you still want to make sure your application is available. So how do I make sure that when I deploy my application or my virtual machine, let's say in the US, it is highly available? This is where we do something called availability zones. Each availability zone is a cluster of data centers where eventually your resource will be in that data center. The availability zones are isolated from one another to avoid any disasters or earthquakes or stuff like that. Usually they are around 60 miles away from each other. So you can make your application available within the region by simply hosting your application in two different data centers in two different availability zones. There are more than 100 availability zones available as we speak now that you can choose from. What you cannot pick is which data center inside the availability zone you want to host your virtual machine. In fact, you don't have visibility over how many virtual machines, how many data centers does AWS have. You also don't know where those data centers are geographically located. Are they underground? Are they above the ground? Are they in the downtown? Are they in the desert? No one knows. When you go over the road, there is no sign on the roads to tell you where those data centers. When you go to Google Maps and you try to search US AWS data center, you will find nothing. And this goes back to the compliance and the security that they are trying to achieve. Only very limited people who are working in that data center, they will know exactly where it is because they need, at the end of the day, to maintain it. So when you deploy your virtual machine or your resource, you can pick a region and you can pick to either deploy it in one AZ or different AZs to make it redundant. We call it multi-AZ deployment. You can take it to the next level and do multi-region design for the sake of putting your application as close as possible to the users in that case. So region is simply a separate geographical location with multiple locations, or multiple at that point availability zones, that are isolated from each other. Availability zones, so inside the region, you have 2 or more availability zones. If I remember, as we speak now, the minimum will be 2 availability zones, and the maximum is around 6 availability zones per region. The availability zone is a cluster of data centers. Between the availability zones, of course, they are connected together using a low latency links. The idea behind them is that to really create high availability for your application within the region. When a natural disaster or a fault that might happen, what AWS have done at the back end, they isolated the failures between the availability zones from one another. So if AWS knows there could be an earthquake that can hit 2 different areas, AWS would not build 2 zones on the same fault domain. That's why it is designed in a way with taking, like, I don't know, physics, geometry, or whatever you name it, people who did it, they took that into consideration when they were trying to choose where should we host those data centers. So if I go to the AWS global infrastructure, here you can see that we do have around 32 regions as we speak now, and there is 102 availability zone out there. There is also a nice map that shows you what are the current regions that they have. So for example, if you hover your mouse over South Africa, you can see there is one in Cape Town that they launched 3 years ago, and inside it, there are 3 availability zones. If you go, for example, to the US, they have multiple regions in the US because US is such a big country. So they have one in North Virginia. Inside it, there are 6 availability zones. They have one, for example, in Canada. They have one in Ohio. You will also notice some of the regions are called government cloud. Okay, so what is this? This is a special region designed for governmental purposes. So something like that, such as the AWS government cloud, this is used by the US government to simply host their data. Not anyone is allowed to go there, only probably the governmental companies. And usually that region will have more compliance and more stronger policies compared to the other regions. Because, for example, the data should remain within the US. So that's why if you host something here, it's quite different in terms of policies because the data cannot leave. So you cannot replicate your data to a different region outside of the US, for instance. You will also see that there is something here called points of presence. So what is this? What is the point of presence in that case, or AKA what we call it sometimes edge locations? You see, we do have, if I, again, go ahead to the board's black screen. Let's say I have my virtual machine hosted in one of the availability zones in one of the regions within the US, okay? And now I have users coming maybe all the way from UAE to access my data, to access my applications, right? Maybe that application is like video streaming, right? Something like Netflix, for instance. Because they are really far from each other, that can cause some latency. So what are the options? What are the solutions? I know what you're thinking now. Well, solution is maybe I can take then my application, replicate all the data to a region, right? Which is within the UAE. Which is correct. That is actually a right answer. But there is a better solution than that. Creating your resources and replicating your data between regions is not an easy operation, right? It's also costly because now, if you are paying $10 to host your application, now you're doing your environment twice, and now you're going to pay $20. And hey, I'm only talking now about users coming from UAE. Maybe later on, your application is going to be really famous and you might have different countries. Does that mean that I have to go and keep replicating my application over and over again in different regions, and just my cost is like exponentially increasing? And they said there are solutions for that. And one of those solutions is you can use something called edge location. Okay, what is an edge location? Basically, this is a caching location. So rather than you creating your virtual machines and stuff like that, what we can do is we can take all the recent data and we put it here. We take a copy of it and we put it in the edge location. And that edge location is somewhere close to the users. When the user is trying to read or write something on the application, they can go to the edge location to fetch the data from there, which is as close as possible to the user, rather than going all the way back to the original region where I hosted my resource. Reducing latency, giving a better user experience, and cheaper than replicating your design in a closer region. This is what we call it a point of presence. And as we speak now, there are more than 550 edge locations that AWS have designed so far. And this number keeps increasing every single month. So those are not regions, right? You cannot really go and create your resources in an edge location, but what you can do is you can use it for caching purposes. So the key takeaways, if you want to kind of take a step back and see, all right, so why we really need the cloud, why we need AWS, it's all about the flexibility and adaptability to accommodate workloads at any scale. What we are about to do next is looking at some of the most common AWS services that you can use on the AWS Cloud Portal. Starting with the compute. This is probably the first fundamental service that you need to learn. What if I want to host my application on AWS? Well, we offer you a range of services that allow you to run your compute resources on AWS, from virtual machines to containers to something called serverless, while making sure your application is highly available, is being auto-scaled up or down on its own. What are the different use cases which I can leverage if I want to use the compute in AWS? Well, it doesn't matter if you do have a general purpose application or you want your application to be optimized for specific needs. As an example, someone is saying that, hey, I'm using AI, machine learning. I want to make sure that the virtual machine I have is high performance computing machine, right? An HPC. Does AWS offer a virtual machine with a really good amount of GPU or certain technologies that allow me to run this? And the answer is yes. Okay, you know what? For compliance reasons, I want my virtual machines to be dedicated, to be installed on a dedicated server. I do not want to share my server with any other customer. Can AWS do this for me? Yes, we can, bare metal. Okay, I want my storage to be on the same or to be directly attached as my application. Both of them should be on the same server. Can AWS do that? We do have attached storage. Okay, you know what? My application is network intensive. It requires 100 gig or maybe 400 gig of bandwidth. Do we have this on AWS? Yes, we do. Enhanced networking. So really, regardless of the use case, security-wise, high performance, low performance, generic, I will show you in a minute that when we go to the console, all of those services are just available for you in a drop-down menu, and you select which one that matches your criteria or your scenario for your customer. And one of the most popular services out there is Amazon EC2. Amazon EC2 is a service that allow you to create a virtual machine on AWS. With a small difference when you compare that to the on-premises. In on-premises, to create a virtual machine, usually you get the hardware, right, from one of your favorite vendors. On top of the hardware, you go ahead and install a hypervisor, right? You could get something like VMware, E6i, or maybe a Microsoft Hyper-V. And then on top of that, you go ahead and start create your virtual machine. For each virtual machine, you have to get an operating system like Windows or Linux, depends on your application. And then finally, you install your application. Your responsibility is everything from the application all the way down to the hardware. That is your responsibility. You need to maintain the hardware, make sure it's up and running, right? You need to maintain the hypervisor, update its versions, create all the required VLANs and networking there. Then you need to get the OVA template, import it in the hypervisor, right? And then install the operating system, and then eventually get the application installed on all of that. Operating system is your responsibility, hypervisor, hardware, and the application. Can I get the same look and feel on AWS? Yes, you can. With a small difference, I'm going to choose some of the AWS colors, right? When you do an EC2 instance, this is where you can get the operating system plus the application. Everything else, AWS is going to take care of that. So hardware, not your responsibility anymore. AWS will take care of that on behalf of you. How about the hypervisor? You don't have access to that. It's not your responsibility. AWS will also take care of that on behalf of you. How about the operating system? Well, you can choose. When you create the EC2 instance, you can tell me which operating system you want. Maybe I want Windows. Maybe I want Linux. Maybe I want Mac. Whatever you want, you just select it, and we will pre-install the operating system for you. So really, that means all you need is just to host your application on top of your EC2 instance, and you're good to go. Eliminating the idea of making sure that the hardware is running as I expect, or the hypervisor, etc., etc. So the idea behind EC2 is to give you the opportunity to boot server instances in minutes by just giving you a form which you need to fill. Based on what you're going to fill, we're going to go ahead and create that virtual machine for you. When you create the virtual machine, you start to pay for it. When you don't need it, you simply say, thank you very much, I don't need it. You stop it, or you can even terminate it, and then you will stop paying for that. You can even save money on AWS by committing to a certain period. You know, by default, we're doing something called on-demand instances, which think about it like you want to go on a vacation, right? So you're going to a vacation, you step into the hotel, you pay for whatever the room rate today. You don't reserve anything in advance. But you know what? If you know that you're going for a vacation next month, you can go for an application like booking.com or Agoda or whatever you use. And then you can say, I want to book from this date to that date. And then they can give you offers, right? So you reserve, you commit to a certain period, right? But as a result of that commitment, you actually save money. This is the second approach. So it's not just about creating virtual machines on the fly, but it's also about saving money on those virtual machines. And to create those virtual machines, all you need to do is you create an account on AWS. When you create an account, you get access to something called the AWS Management Console. This is what you see in front of you here. And on the Management Console, this is where you can manage your resources. You can create them on the fly, modify them, delete them, pay for that, and all of those stuff is done from one place. Is that the only way to create resources? No, there are actually 3 different ways to create resources in AWS. One of them is the console. This is like the easy way of doing it. But we also have at the back end AWS CLI. So you can go ahead and, for the people who are coming from a network background or a Linux experience, they can go ahead and install that AWS CLI on a Linux machine and then configure AWS resources using CLI, but also AWS providing an SDK, software development kit. So you can also write your favorite programming language, such as Python, to create those resources as part of your code. For now, we're using, it's the basic level in that case. So we're using the easiest way, which is the AWS Management Console. Once you log into the AWS Management Console, here on the left-hand side, you see the list of services provided by AWS. They are categorized here by, what exactly you're trying to do, or maybe you can click on all services, and here they will be organized in an alphabetical way. In that case, we're trying to create a virtual machine. So I'm going to go click on the compute, trying to create a virtual machine. And you can see there are so many services that allow me to run an application, different services for different scenarios. For now, our focus is, I'm trying to do virtual servers on the cloud. But you know what? Maybe what I'm trying to do is instead of running a virtual machine, trying to run a container. So there is a service down here for the containers and stuff like that. So for now, I'll click on the EC2. I just want to show you how easy it is to create a resource. And this is where you get to something called the service dashboard, where you can see, all right, do you have any virtual machines running as we speak now? And currently there is 0 instances. So what I can do is I can go to the instances over here on the left-hand side, and I can say that, all right, I want to launch a new instance. This is the process of creating a virtual machine. Okay, when you want to launch an instance, we give you a form that you need to fill. The result of what you are going to enter here, we will take those as the settings that will be deployed to the virtual machine. So what are you trying to do? Okay, maybe I'm trying to do something like Linux machine as an example. Okay, choose what is the operating system that you want for this EC2 in that case. So maybe we can go with the Amazon Linux, but pay attention, I'm not limited to that, right? You can choose stuff such as Ubuntu, Windows, Red Hat. You can even click on browse more AMIs. And instead of just choosing maybe an OVA template, this is like very similar to the OVA. We call it Amazon Machine Image. And instead of just choosing the operating system, I can choose a template that has the operating system plus the application. Like imagine, what if I want to install a firewall on AWS? So I can go to something called the marketplace, which is an AWS and a trusted third-party AMIs. And look at that. There are pre-packaged virtual machines, such as if I want to install Fortinet next generation firewall, if I want to do a Palo Alto next generation firewall, I can even install stuff such as routers, for example, something like Cisco virtual routers, stuff such as CSR. So think of this like an OVA template that you usually get on premises. So you can choose to only have the operating system pre-installed, or you can have the operating system plus an application pre-installed. In that case, I will just cancel that one. And I'm going to go with like the traditional Amazon Linux in that case, just a basic Linux operating system. You can play around with the stuff such as the architecture if you want. You can choose the instance type. All right, so what is the instance type? What are the amount of resources that you want on that virtual machine? You can start all the way from one virtual CPU and 1 gig of RAM, right? All the way, if I filter that, give me like the highest CPU that you have, all the way to having like almost 450 virtual CPUs with around 6 terabyte of RAM. Okay, so this is for CPU intensive. Maybe no. Actually, my application is memory intensive. So I can go ahead and filter, give me the highest memory you have. Well, we have stuff goes up to 600. 6,000 gigabytes, 6 tera RAM. This is one virtual machine I'm talking about here. Yeah. In the future, I can have more than one instance. And all of them together, they make up the resource which I'm looking for. So this is just for a single virtual machine, what we're looking at here. You can choose stuff such as the storage type. Okay, how much storage do you want? Do you want SSD? Do you want HDD? What is the maximum input output? So as you see, it's a group of questions that you ask. So in this case, I'll just choose something called the T2 micro. You can define stuff such as key pair, which allow you to SSH into your instance, stuff like creating a private key and a public key, for example. So I can go ahead and maybe create one. You can define the network settings, such as, okay, do you want your virtual machine to have a public IP address or not? You can also control something called the subnet. So if I edit this one, the subnet allow you to control which availability zone you want this virtual machine to be a part of. Notice on the top right-hand side here, I selected Paris, which means I'm creating this virtual machine within Paris. And inside that region, there are 3 availability zones. So you can pick one of them to simply create that virtual machine in there. Or you can leave it no preference. No preference, it means AWS will just select an availability zone on behalf of you. You can configure stuff such as security group, which controls what are the inbound ports that is allowed to your virtual machine. Do you want to allow people to SSH, for example? Do you want to allow people to ping your virtual machine? So you can actually control that from here. This is as if like you are adjusting the firewall rules of your operating system. But now you can do that on the console itself. So maybe what I want is, okay, I can go ahead and try to SSH from anywhere. So using any IP address, but I can also define certain source IP addresses. And what I'm doing here is I'm simply allowing SSH from anywhere. That's the description. I can keep adding more rules if I wanted. You can also define the storage, right? What is the storage that will be used by this virtual machine? Do you want 8 gig, 10 gig, stuff like that? By default, when you create a virtual machine, there's something called the root volume, which is a block storage that will save the operating system files and stuff like that. But you can use block level. You can even add something called the network file system at the back end for this virtual machine. Once you're done, you see right here in the summary. All right, so this is what you picked. You want a Linux. That is the amount of CPU and RAM you want. Here is the security group. Here is the storage. You want to create 1, 2, 3, 4 virtual machines. How many do you want? For now, I want 1, but you know what? Maybe actually I want 3 virtual machines. And the system will create all of them for me on the fly. Once I'm done defining that and I'm happy with those settings, I can click on launch an instance. And at the back end, the virtual machine will be created for me. So if I go back to the instances, notice the status is pending. Let's just give it a couple of minutes, even less than that. And that's it. You have a virtual machine running on AWS. Did you notice how long did it take us to create a virtual machine? I'm trying to just transfer, the experience to you. Compare this to what we used to do on premises. Logging into the hypervisor, importing the OVA image, right? Defining all the network-related parameters, making sure that the switch is connected and allowing the VLAN on the trunk, making sure of doing inter-VLAN routing. Guess what? You have a virtual machine up and running on AWS. That virtual machine, as we speak now, have a public IP address. I can go ahead and use the application of my choice to maybe SSH into that machine, and voila, I'm in. Took me like, what, 20 seconds to get that done? That's what we mean by saying rapid deployment, right? Agility. As long as your resource is running, you are paying for that. If you want to stop paying for that, I can go to actions, and I can manage something called the instance state. So I can do that from here, or I can do that from here. So I can stop, reboot, or terminate, or I can even right click any of my resources. So again, different ways to do the same thing. Maybe what I want is I want to stop paying for that. So I can go ahead and stop the instance, stop the virtual machine. Within a few seconds, the virtual machine will be in stop the state, and I stop paying for that. So I saved my config, right? It's there, but I'm not paying for it anymore because currently it is in a stopped state. No long-term commitments. You pay only for the seconds that your instance are in running state. Later on, oh, I need more resources now. I can go ahead and create more instances if I want, or I can start this instance again, or I can even, if I don't need it anymore, I can completely terminate it, which means I want to remove it from my AWS account. Okay, that's good, Nader, that we have, that sort of look and feel of having the stuff on demand whenever we need it. But I'm concerned about scalability. How can I predict how many virtual machines I have? And the answer is, you don't. We have a feature called auto scaling feature. Rather than adding your virtual machines manually and stuff like that, you can make your AWS to automatically add or remove EC2 instances or virtual machines on the fly based on the demand. Think about it this way. What is the black screen? Here we go. So initially, maybe I have 3 virtual machines created, right? We're going to use the AWS terminology now since we know them. EC2 instances. Very good. Those EC2 instances, maybe they have the application, which is my Amazon.com. What happened is those 3 instances was really good. They were really enough, right? To simply respond to the users who are trying to access our website. Very good. But now, guess what? It's Prime Day. Uh-oh. Prime Day, that means the number of users who are about to visit our portal are going to maybe exponentially expand because they want to leverage the nice offers that we have on that day. So what I need to do is to add extra EC2 instances to accommodate that extra workload, right? Otherwise, those EC2 instances might be overloaded because you don't have enough CPU and memory. What can I do then to make sure I'm ready for that? There is a configuration called auto scaling group that you can do on AWS. In the auto scaling group, you can define, for example, what exactly you are trying to monitor. Maybe I'm monitoring the CPU of those instances. And I can configure a threshold, like a condition and an action. I can say, listen, if the average CPU for those instances goes over 70%, then I want you to go and automatically, without me touching my environment, I want you to go and automatically add extra virtual machines, extra EC2 instances, so you can accommodate this workload. Not only that, maybe right now we accommodated the workload, that's really nice, and the Prime Day is completed. So now I have extra resources which I don't need. I can configure the other way around. I can do something called, all right, if the CPU goes less than 30%, right? Because now we don't have a load, then I want you to go and automatically remove EC2 instances so you can accommodate to demand on the fly. This is called scale out. Scale out means I'm adding extra workload on the fly. And this is called the scale in. I'm removing workloads when I don't need them. And when I remove them, I stop paying for them. You can also protect yourself, of course, by defining a maximum number of virtual machines that you do not want to cross, because when you have more virtual machines, you're simply paying for that, right? So maybe you can say, all right, I don't want to go over 10 virtual machines. You can also specify a minimum number of virtual machines that you do not want to go below. So we support having minimum and maximum virtual machines. And then AWS is going to monitor based on the criteria you specify. We can monitor what is happening between this window, and we add and remove resources on the fly. So this is what we call it EC2 auto-scaling, where we can combine dynamic and predictive scaling methods to support your scaling strategy. It's used to add new instances only when necessary, remove unneeded instances by scaling in when the traffic is low, and you only pay for the time you use that. So when you compare that on premises, this is where really the cloud comes in a very beneficial way. In a traditional data center, the scalability usually of your system is bound by your hardware. Here in the slide, we see an example of a basic web application that is running on AWS. This application allows employees maybe to search for conference room that they might want to use for meetings. During the beginning of the week, the usage of the application is minimal. During the middle of the week, more employees are scheduling meetings. So the demand of the application, as you can see, increases significantly. In a data center, anticipating periods of heavy use require you to spin up enough physical servers to handle that extra workloads. But then what happens when those servers are not used for the rest of the time? They just sit idle in the data center. Isn't that a waste of money in that case? So that's why the cloud is kind of giving you that demand in a programmatic way. It enables you to take a more flexible approach to the idea of scaling. You add new instances when necessary, you terminate them when you no longer need them. The auto-scaling group itself, as a feature, it's free. You only pay for the resources that are added by the auto-scaling group. Let's say I went through this, I did the configuration. How can I make sure, right? Now when a user is trying to access, going back to our initial e-commerce app, when my user is trying to access Amazon.com, how do I make sure that the traffic is being distributed in an even way across all of those virtual machines that I have created? Well, we have a very common service called the load balancer. Okay, do I need to create the load balancer by myself? And the answer is no. AWS also provide you with a managed elastic load balancing service that can distribute the incoming application across multiple resources, such as virtual machine. So from the outside, they don't need to know the IP address of the virtual machines, right? The only thing that you expose is your load balancer. So it might have a public IP address, for example, but you keep your virtual machines private by only giving them private IPs on AWS. And at the back end, the load balancer is going to go ahead and distribute that traffic in an even way across your virtual machines. So combining both of them together. So when you have low demand, right, you only have maybe 2 virtual machines at the beginning, 2 EC2 instances. Fair enough. How are you load balancing between this? You're using the elastic load balancer. At a certain time, you have a spike. So the auto-scaling group decided to add extra virtual machines to your environment. Now look at that. The auto-scaling group feature can automatically integrate with the load balancer which you have created. So the additional virtual machines that were automatically created, they will be automatically added to the load balancer. No changes in the configuration required. So this is another benefit when you think about it. We're here leveraging automation, if you think about it, right? If I want to do the same thing on premises, when I add those servers, that means I have to go jump on the load balancer, change the configuration, right? To make sure that those new IP addresses of the new version machines are going to be supported and the load balancer is going to be using them. We have different types of load balancers. You can have an application load balancer, which can do load balancing all the way up to layer 7. That means the load balancer can look into the URL, which is being used, and then it can send it to the right virtual machine, which is serving that purpose. An example for that is a user at the beginning is trying to go ahead and access your application. So it will hit the application load balancer using DNS. The application load balancer have the ability to inspect the HTTP or HTTPS request to look at something such as the URL. At the back end, you can divide your virtual machines into something called target groups. So you're saying that if the user is trying to hit something, a URL that ends with images, you are supposed to send it to those groups of the virtual machines. You should load balance among those groups. If he's trying to send a different URL, send it to a different group of EC2 instances. So it's not just about, basic load balancing, but you can also configure rules, and those rules can make the application load balancer aware of the traffic that is being received, and then it can send it to the correct destination based on your choice. Another flavor of computing, rather than doing virtual machines, you can do something called elastic container service, which allow you to create containers on AWS, which is being used for microservices. You don't need to worry about Kubernetes. You don't need to worry about managing the Docker, right? At the low level of creating the containers. This is all being presented to you as a console interface, as a form, exactly just like what I showed you now. And then you fill in the form, and then we spin up the containers for you. It supports OCI compliant containers, including Docker containers. Docker is the software that allows you to build, test, and also deploy the applications quickly. Another computing service is Lambda. Lambda allows you to run the codes on AWS without the need to provision or manage servers. Think about it this way. If I have a developer, right? And what the developer usually care about is, oh, I have a code. I'm a developer guy, so I only have a code that I want to execute. I don't care about servers, right? I don't care about CPU. I don't care about memory. The system admin is supposed to make all of that stuff ready for me so I can eventually execute my code. But technically, if the developer will use the EC2 service as an example, then at that point, he will have to take care of the operating system, right? And then on top of that operating system, he need maybe to install his IDE environment, something like Visual Studio. And then maybe he need to go ahead and install the programming languages and the compiler or the interpreter that will be used, something like Python. And then on top of that, he put his code. So as you can see, the developer will then have extra responsibilities. He needs to make sure the operating system is secure, the operating system is up to date, the IDE doesn't have any bugs, the programming languages or the compiler is also up to date, all the security fixes are there, and on top of that, he take care of his code. Is there a service that just allowed the developer to go ahead, take their code, put it in AWS, and then click run? And AWS take care of all the operating system, the IDE, and all of that stuff. And this is what AWS Lambda is all about. It allows you to run code on AWS without provisioning or managing servers. You only pay for the compute time that you consume. There is no charge when your code is not running. So this is actually a service, we call it an event-driven. So you can maybe expose your code via something like an API. When someone asks for that API, your code will run. During this running time, maybe it runs for 1 second, 2 seconds, depends on what you want to do. This is what you get billed for. If no one is executing the code, then you don't pay for that. So to use Lambda, what you simply do is you can take your code, upload it to AWS, or you can even write it over there. And then you set an event source, which is how your code is supposed to be triggered. And then your code run will trigger. And when the code runs, you will only pay for that compute time which you use. So different computing flavors. Of course, this is not the only ones. We are just trying to highlight the main ones as it stands now. You learn more about every one of those services, the configuration and the settings within the AWS training, such as architecting on AWS, as for instance. Okay, how about storage? What if I want to save my data on AWS? Well, AWS gives you different storage offerings, from block level storage, such as EBS, to file level storage, such as EFS, to block level storage, such as Amazon S3. And finally, we have something called Amazon FSx, which allow you to create a Windows file share, or you can use your favorite third-party file system, such as NetApp ONTAP file system. S3, this is scalable, durable object storage that you can access from any internet location. It can be used for many purposes, such as static websites, can be used for archive, it can be used for big data storage, and so on. It's considered to be one of the serverless features. So you don't need to worry about scaling your storage. It will scale on its own, right? So the more files you add in, the more scale it will simply expand if you think about it in its own. When you upload your data, you have to create a bucket. You can make your bucket public or private. Public, it means it's accessible over the internet. Private, it means it can be only be accessed within AWS or within the VPC. What you can also do is you can do versioning. So when you upload your data, you can create version 1, version 2, version 3 out of your file. You can also activate features such as multi-factor authentication. So you make sure that no one is going to delete any files in your storage unless maybe they send you a code in your phone. So you can have two forms of authentication before being able to delete any object or any file within your S3. The other option is the EBS. This is a block level storage that comes with your virtual machines. You can use it for stuff such as relational or NoSQL databases. You can use it for data warehousing. You can choose between SSDs or HDDs. So we can give you different input output and different amount of throughput as well. So we provide you with SSD or HDD. HDDs are going to be cheaper than the SSD, but they will give you lower performance. And I don't know if you noticed that or not, but when I was launching my virtual machine, if we click on launch instance, just to show you how it looks, give it a minute. Part of the settings of defining the virtual machine, if I go down, you should be able to see a section related to the storage. And here we go. And by default, a virtual machine will actually have an 8 gig of an EBS volume. It's a block level storage, and it's using an SSD. And this is what we call it the root volume of the virtual machine. And the root volume is used to store the operating system of your files, the operating system of your, the files of your operating system. But you can also go ahead and add extra volume. Think about this like a C drive and a D drive. The C drive, I can choose between SSDs. Probably I want my operating system to be fast, right? Oh, and for the extra space, maybe I can go ahead and use HDD. It's going to give me lower performance, low input output per second, lower throughput, but overall, it's going to be cheaper. And all of those stuff, as you can see, I edit them on the fly. So if I need more storage, I can go ahead and add that, and it's automatically attached to your EC2. If I don't need it, I can go ahead and remove that. We call this the provision capacity, and the more space you will allocate, the more you are going to pay. So what you can do is the virtual machine will already have an an EBS volume attached to it, but I can go ahead and create additional EBS volumes and attach it to my virtual machine on the fly as I need. EBS volumes are block level storage. What if I need file level storage? Maybe I have a Linux operating system and I want to use NFS. Is there a service that allow me to create an NFS file storage and allocate it to my virtual machines? And this is what we call it EFS, Elastic File System. This is a managed NFS storage. It supports NFS version 4.0 and 4.1. So you get the latest authentication, you get the latest encryption protocols. It supports high availability due to the fact that you can store your data among multiple availability zones. So it's a dynamic, it's a shared file storage, It's cost effective because, again, you only pay for the amount of storage that you use when you consume your NFS. It's pretty much the same concepts, right? I think you started to get the idea by now. Most of the services are similar to the stuff I have on premises. I just offer it to you on the cloud in a shape of a form. The more resources you want, the more you're going to pay for that. How about databases? What if I want to have a SQL database? What if I want to have a NoSQL database? Can I do that? Yes, you can. Option one, again, I'm trying to make you imagine how it would look. I can have an EC2 instance created, right? So the EC2 instance, it will do what? It will give you an operating system. And then on top of it, I can install my database as an application. Correct. But then if I follow this approach, now I'm responsible for the operating system. I'm responsible for the EC2. So I need to make sure there is an auto-scaling group over there. I make sure that I can scale my database. I'm responsible for the backup and all of that. Can you give me the database as a managed service? I don't want to manage the EC2. You take care of the EC2 on behalf of me. And this is what the database services are. We offer you a relational database service, just to name a few, RDS. We offer you a NoSQL database, such as DynamoDB serverless, and we can also offer you migration services. So you can migrate your on-premises database to the cloud, vice versa, or even to convert a database engine from one to another, such as converting maybe from MySQL to Oracle or vice versa. RDS is a service that is super easy to set up, operate, and scale, which allow you to create a relational database on the cloud. We give you a form that you need to fill. In that form, you can tell me what type of engine do you want. You want MySQL, you want MariaDB, you want Oracle, you want Postgres SQL. We ask you extra questions like, do you want to have a single RDS instance or do you want to deploy this in multiple availability zones? Of course, if you choose multi-AZ, you have to pay more because now you're using double resources in different availability zones. Do you want us to replicate your data from one to another? Do you want to have a primary database and a secondary database? You see that? So this is all happening just by defining a form. You do not need to manage the underlying resources that comes with the RDS database. Similar idea goes to the DynamoDB. DynamoDB is a key value and a document database that can deliver a single millisecond performance. You go over there and you just go ahead and create tables. In the tables, you can have keys and attributes, which are, think about it like rows and columns. But at the back end, you don't need to think about the multi-region. You need to think about the multi-availability zone. AWS can take this from you. So even when you compare that to the RDS, you have to define the multi-AZ by yourself. The DynamoDB is, you don't need that. It's just as a service, you go there and you can start using it right away. The RDS is relational. The DynamoDB is a non-relational or a NoSQL in that case. Different use cases could be using the DynamoDB, such as mobile backends, gaming, Internet of Things. Think about any application that can benefit from a database that can automatically scale up or scale down, and you can access it via API, which pretty much have a large dimension of applications which could be supported, regardless of their operating system, Linux, Windows, iOS, Androids, etc., etc. Finally, what if I have a database and that database is on premises and I want to migrate it to the cloud? Is there a service that allow me to migrate my data? And this is what DMS or database migration service. It allows you to migrate data to and from the most widely used commercial and open source databases. Migration can be from on-premises to maybe RDS or EC2, or vice versa. You can also use it to convert your database engine, maybe from SQL to Oracle. So it has something called schema conversion as well, in case you want to change your database engine while you're moving it to the cloud. One more section related to the AWS services is networking and content delivery. For network engineers, first thing to come in mind is when I'm hosting all of those virtual machines, do I have control over the networking settings on AWS? And the answer is yes. We do have service that allow you to isolate your resources called VPC. We'd have a DNS service that allow you to register your domains, create your DNS policies. We do have a service that allow you to privately connect your on-premises to the AWS. We call it Direct Connect. We have a service that allow you to use the edge locations for caching called the CloudFront. And we also have a service to centralize and convert your full mesh topology into star topology. We call it Transit Gateway. First, VPC. What is VPC? This is called Virtual Private Cloud. When you create any resource on AWS, it needs to take an IP address. And if you want to compare this to on-premises, think about it like a VRF. Any resource needs to belong to a network. That network could be private, it could be public, right? I also define subnets in that network. This is what I refer to as VPC. By default, when you create your account, it comes with a default VPC, but you can create extra VPCs and make them private in that case. Inside the VPC, you put all your subnets, you put all your NAT gateways, network gateways, IPv4, or even IPv6 subnets. That's why you have full control over making your resources public or private by modifying your VPC settings. To get started with the VPC, just to show you the look and feel behind it, let me move to that slide. So how does it look is you go in AWS, you want to host your resources there. So the first thing you do, right, is picking a region. Okay, which region I'm going to host my resources? More likely, you will choose the region which is close to your users. Once I have the region in place, inside the region, I create a VPC, Virtual Private Cloud, which represents my network on AWS. Inside that network, I have something called subnets. Subnets could be public or private. The virtual machines in the public subnet, they will have a public IP. That's why they are accessible from the internet, similar to the virtual machine that I just created. The resources created in the private subnet, they will only have private IP. That's why they are not accessible over the internet. Why would I do that? Well, think about it this way. Maybe my load balancer, if I have a load balancer, the load balancer should be in the public subnet, so it will have a public IP. But then my applications themselves, they could be in the private subnet, so they are not exposed to the internet. People come, access my application via the load balancer. So that gives you a very good amount of control on what resources should be publicly accessible and what resources should remain private. The other service related to networking is Route 53, which is a scalable cloud domain name system. It's a DNS service. Think about it this way. If I have the users trying to visit my application, which is my EC2 instance, How will they access my virtual machine? Well, probably I need a URL, right? www.amazon.com. Very well. Where is the DNS service? One of the options you have on AWS is something called Route 53, which is a highly available, global, and scalable DNS service. The users can go ahead, reach to their nearest Route 53 service based on their location. The Route 53 can resolve the name into IP, and then you can go ahead and access my EC2. So over there, you can create DNS policies such as latency, weighted policy. You can use it as well to balance or redirect the user to go to the application instance, which is closer to their location, as an example. You can also use it to create your own DNS records. So rather than maybe going to certain websites such as GoDaddy to register your domain, you can also purchase the domain from the Route 53 service. So this is how it looks in a nutshell, right? So when you have your applications running within your network, within your VPC, and maybe in front of the application, you have the load balancers, and you want the users simply need to go ahead and access the load balancer, I can go ahead and put in a front end a domain. So the user go ahead and get directed to the Route 53. Based on some policies which you may define there, the Route 53 can return the IP of the load balancer that maybe belong to the right region, which is close to that user. Or you can configure the DNS to maybe return all the IP addresses of all the load balancers. Now, what if I'm using hybrid networking? I have some resources on premises within my data center. And at the same time, I have also some resources hosted in AWS. How can I connect my on-premises data center to AWS? There are a couple of options we gave you here. One of them is that you can actually use the internet, and for security reasons, you can do a VPN, such as an IPsec VPN over the internet. At that point, this is a very easy to install, very easy to set up, right? But there might be some concerns about the bandwidth throughput. Do I have a consistent network experience? How is my internet connection is behaving like? So for customers who wants to have a consistent performance, a consistent experience, a better network bandwidth, there is another option called Direct Connect. And think about this as if it's a private connection that is used between your own premises and the nearest AWS facility. Of course, this is going to be more expensive than the internet VPN, but at that time, you have better bandwidth throughput, you have a better network experience, right? You have a private connectivity between your data center, office, or whatever co-location environment and AWS. CloudFront is the name of the service that allow you to use the edge locations from AWS. If I move a couple of slides just in front, take this as an example. Maybe I have a video streaming application, and the video streaming, I hosted it in one of the regions. Maybe something like in South America or stuff like that. And then I have users coming all the way from Asia trying to access that video or stream that video. The issue that I'm facing is if that user came all the way trying to stream the video from maybe South America, that might introduce some latency and delay. As a solution for that, I can use a service called CloudFront, which is going to provide you with a content delivery network, aka caching service. Think about What I can do, rather than recreating my environment in Asia, I can take the most recently used data and cache it within one of the edge location or the point of presence that AWS has. The next time a user is going to go ahead and ask to stream the same video, rather than going all the way back to the region, I can serve it right away from the edge location, allowing you to have a better user experience in that case. You can use it for different purposes, such as static asset caching, for video streaming. When someone is trying to download stuff from your website, well, just cache that data as near as possible to those people. There are no minimum commitments, no upfront charges. You only pay for what you use. So you get a quick delivery of your content to the users, and you only pay for the amount of data that is being cached. Of course, we talk more about that in the architecting on AWS service and how it works, and where you see that on the console, and how long can I keep the cache for. You definitely have full control on what should be cached, how long it should be there, what content should be cached, etc., etc. So the key takeaways here is AWS provides you with an immersive selection of services. In fact, there are more than 200 services available on AWS, and there's no way we can cover that in even one day. But those services are going to provide you with a very advanced functionality that makes it easier, faster, and more cost-effective to migrate your applications to the cloud. With AWS, you can only pay for the services that you use, which means it will help your organization to save costs and run your applications in a more cost-effective manner. Let's go through a quick knowledge check before I show you the last part. We do have a small part at the end related to the security and compliance, but please feel free to interact with me on the chat if you know the answer for those questions. Which AWS service automatically distributes traffic across multiple resources and availability zones? Is it EC2 elastic load balancing, auto scaling, or Lambda? Feel free to answer that on the chat. See, answers are coming in, and the correct answer is actually the EC2 elastic load balancing. The other options are incorrect because the auto scaling is used to automatically add or remove EC2 instances as needed to meet the demand. The Lambda service, this is used for running code, but to load balance the traffic, elastic load balancer is the go-to option. All right, another one. Amazon EC2 is a service that provides highly scalable, high performance container orchestration. True or false? Is it a container service, the EC2? See, answers are coming in. And the correct one is actually false. That is correct. The AWS service that provide highly scalable and high performance container is the ECS, the Elastic Container Service. Amazon EC2 is used to run server instances, or AKA virtual machines on the cloud. Another one related to storage. Which AWS service is the best option to use if you need high performance block storage? Is it EBS? Is it EC2? Is it S3? Block level storage. You needed to focus, I think, here between the lines to try to capture that. But the correct one here would actually be EBS. This is the block level storage. The EC2, this one enable you to launch a server. It's not really a storage. And the S3, this one enable you to store files as object. It's a object level storage, not a block level storage. Okay. Another one, Amazon Elastic File System, EFS, can store data within only a single availability zone. Is that true or false? We went over that quickly, but let me tell you something, especially when you go sometimes for AWS, if it looks bad, if the question actually sounds bad, that is more likely mean the answer is wrong. Like if it's a single availability zone, okay, that's a single point of failure. So you know what? AWS wouldn't do that. That's why the answer is usually false. EFS is actually a regional service that can store the data within multiple availability zones for high availability. Okay, one more for the databases. Which AWS service is the best option for a NoSQL database that is serverless? Is it RDS, DynamoDB, or DMS? Yep, and I see the answers coming in. The correct one, which is a NoSQL, non-relational, serverless, is DynamoDB. The other options are incorrect because DMS is the database migration service and RDS is the relational. The NoSQL is an alternative at that case to the traditional relational database. Okay, another one for the databases. Which AWS database service support multiple database engines, including Aurora, MySQL, and PostgreSQL? Is it RDS, Lambda, and S3? That should be easy because only one option actually represents databases. And yep, the correct answer is Amazon actually RDS. The other options are incorrect because the Lambda is a service running code and S3 is a storage service to store files and objects. Sorry, to store objects in that case. Okay, a network question. Which of the following AWS service is a highly available and scalable DNS service? Is it VPC, Route 53, or Direct Connect? Which one of those allow you to have a DNS service? And yep, the correct one is Route 53. Other options incorrect because the Amazon VPC, this one allow you to create a network on AWS, but not really to create a DNS service. And the Direct Connect is the service used to establish a dedicated private connection from on-premises to your cloud. Another network one. Which AWS service allow you to have a fast content delivery network, aka caching? Is it Direct Connect, S3, or CloudFront? And yep, answers are coming in. And the correct one is CloudFront. The other options are incorrect. Direct Connect is for the dedicated connection between on-premises and the cloud, and S3 is used to store the files. That is correct. The final section that we have is related to security. I just want to walk you through some of the security mechanisms. I know that we have been running the session for almost 2 hours now. I just believe that this section is quite important because it may answer so many doubts that customers have. Is it secure to run resources on the cloud? I like the scalability. I like the availability, but is it secure? So what are the key things that usually come in mind when you think about security? Well, some of the ideas that might come in mind when you think about it could be visibility, auditability, controllability, and agility. Visibility means I want to see what is going on within the AWS environment. What happened? Are my services being publicly accessible or privately accessible? Auditability. Who logged into my AWS environment? When did they log in? What did they change when they logged in? Like audit logs. Controllability. I want to have control over my resources. right? I want to be able to encrypt. And when I encrypt, I want to use my own keys, which I only know about maybe the private keys. And agility, the ability to delete, add, remove those security controls on the fly. Just like the way I'm adding resources, I want to be able to repeat the same thing for security. And in AWS, usually we use what we call it the shared responsibility model. When you host your services on AWS, there are some responsibilities related to you as a customer and some services related to AWS as a cloud provider. Let's start with you as a customer at the beginning. You are responsible for what we call it the security in the cloud. Okay, what do I mean by saying that? AWS give you the tools to secure your environment. For example, we give you the option to do something called security group. What are the ports that you want to open or close on your virtual machine? So we give you the tool, right, as an AWS. Your responsibility is to leverage that tool. Your responsibility is to take that, configure it, and open the ports. If you configure it in a way that you opened all the ports on your virtual machine, that is not AWS responsibility. This is your doing in that case. So I want you to think about it in a way that the customer is responsible for the security inside the cloud by leveraging all the tools and implementing them to make sure their design is secure. All the stuff from the operating system, right? Making sure you install the batches on the operating system on your virtual machine, to the application security, to the security group which control the ports, right? By doing the access list, right? Creating username and passwords and stuff like that. So you retain of what security controls or what security features that you want to choose. Now, AWS, on the other hand, is responsible for the security of the cloud. What does that mean is AWS, they operate, manage, and control the components of the infrastructure, such as they take care of the regions, they take care of availability zones and the edge locations. They make sure that those data centers are up and running. They are responsible for the physical security of the data center. They are responsible for the hardware infrastructure from servers, storages, etc., etc. But also, they are responsible for the software that runs on top of that infrastructure, such as the virtualization engine, for instance, the routers, the switches, the load balancers, the firewalls, the cabling, right? So all the stuff that make up the data center from infrastructure point of view, hardware resources, and virtualization engine, that is AWS responsibility. Then we give you a features to leverage and create resources, and that is your responsibility. Some of the features we give you is stuff such as identity and access management, allow you to create new users or create administrators, detective controls, so you can detect if your environment is in or out of compliance, infrastructure protection by giving you firewalls if needed, data protection by giving you the ability to encrypt your data, and most importantly, we also have compliance. Talking quickly about each one of them, identity and access management allow you to create administrators to have a centralized repository and give them permissions on what they can do. Different services allow you to create users, something like Amazon Cognito, which offers identity management for your applications. Directory service, this is a managed Microsoft Active Directory service that you can have on AWS. The IAM, Identity and Access Management, allow you to create extra administrators and provide permissions to them. AWS Secrets Manager allow you to rotate, manage, and retrieve your passwords from here. So you can save your database passwords and stuff like that, and it can be encrypted. And we also support AWS single sign-on that allow you to integrate with your favorite third-party providers to sign in within AWS service. For detective controls, we give you stuff such as Security Hub, which is a unified security and compliance center. Guardy Duty, which is a threat detection service on AWS. Amazon Inspector, this is a service that can analyze your application security and give you feedback if the application is secure or not, according to AWS best practice. And then you have something called Amazon Massey, which is a service that can allow you to discover, classify, and protect your data. So it can read the data and then classify it, and then it can tell you, oh, this is a critical data, it's a personal info, you should encrypt that. Infrastructure protection is giving you via firewalls. You can bring your own firewall and install it inside your virtual machine, or AWS provide you with a managed firewall services, such as Shield, which is a firewall that gives you a distributed denial of service protection. Then you have the WAF, web application firewall, which allow you to have a next generation firewall, and it can filter the malicious traffic within the layer 7. It's a layer 7 firewall. And then you have the firewall manager, which is a dashboard, allow you to manage all the access lists for the firewall, central management for the firewall rules in that case. Data protection. How do I protect my data? I can encrypt the data by using the KMS service. This is a service that can be used to encrypt and decrypt your data by generating keys and save them in AWS. Or you can even use an on-premises software, something called Cloud HSM, which is a hardware-based key storage for customers looking for compliance. And we also have a certificate manager that can act as a certificate authority to provision, deploy, and generate SSL and TLS certificates. Finally, we also have the feature for the compliance. What if, for example, I have a customer who wants to deploy the resources within UAE? And within UAE, there is a certain regulatory requirements and agreements that this customer must agree on before hosting their data. Where can I find those agreements? How can I make sure that I'm compliant with the UAE regulations? That's where we have the compliance, something called AWS Artifacts, which is a self-service portal, which is free of charge, which shows you all the compliance reports for a certain country. And you can then go ahead and download those reports, read them, and then further down the road, there are services which you can configure that can review your existing deployment on AWS, and then it can tell you whether you are compliant or not. And then it can also give you recommendations on what you need to change to actually be compliant. That was a dose of what you can see on AWS. Our goal, as I told you, was to discover really AWS. We were not trying to make you an expert, rather than just giving you an introduction, right, on what AWS is offering, how can you make your changes and your configuration. There is a range of trainings that we recommend you to follow up, such as the architecting on AWS, where you can actually dive deeper into each one of those services. We get more hands-on, you get more practical when you also go to those trainings. I hope this session, it's a short one, it's a small nugget, but we were trying to accommodate as many concepts as we can as part of our webinar. Let's go ahead and check questions that you guys might have. More than happy to take on any questions. Feel free to shoot them on the chat.
Thank you so much, Nadir, for this session. It's even though it was for around 2 hours, but it's time has flied. It was very nice. So earlier in the session, Just Joy had requested, or she asked if it is possible to export the VM locally.
That is correct. Yes. So one of the options, you actually have not only import, but you can also export. So do you see those AMIs, which we have been using to create the EC2 instances? You actually have here something called an AMI image, and you can create your own AMI image by even taking an existing OVA and importing it into AWS, or the other way around. If you have created an image, you can take it and then export it into maybe an OVA which you can use. And this can be done using something called the EC2 image builder, which is a service inside the or under the EC2 category, if you put it that way. And that service allow you to take your OVA, right, and then customize it, convert it into an AMI, or even vice versa. And all of that again is a fully managed. So yeah, the answer is yes, you can.
Great. So we also have a question from Eli that asks, after AWS practitioner, is it best to go solution architect first or DevOps?
DevOps is going to be a little bit more advanced, to be honest. Personally, I would go for the solution architect. The reason why, because in the DevOps, we're kind of trying to teach you how to automate the services on AWS. But at the first place, you need to know the services, right? So this is where the solution architect associate is really important, along with the cloud practitioner, where you learn about the services, you learn how to deal with them from the console, and then we show you how to automate that, how to take that and put it as a part of CI/CD pipeline, how to use Python, how to use templates, stuff like Terraform, where you can automatically spin up the entire AWS environment with just a few commands. But before you go there, you really have to go through the practitioner and the architect associate. If you already have cloud background, then you can actually skip the cloud practitioner, even though it's just like an on-demand video. It's a one-day video, and you can jump to the solution architect right away. My advice is actually take the solution architect as an instructor led, just to have the base knowledge. And then later on, it's up to you if you want to continue with instructor led trainings, or you can just go ahead and read the documentations to understand the rest of the services. But you just need a starting point, and the solution architect is really like the most popular certification, because it gives you that first baby step into the world of cloud computing.
Eli says, much appreciated. So in solution arc, it will help in containers, Docker, and Terraform.
Correct.
Khalid is asking, what is your recommendation for an IT network engineer to do in the cloud industry?
Well, that's a good one, because throughout my entire life, I have been a network engineer. And one way or another, cloud is gonna step into your domain. At some point, you will have a customer to tell you that, listen, I have a data center on premises. I want to have VXLAN or BGP EVPN all the way to the cloud. And then you'll be like, how do I do that? That's why you need to be aware of what is happening on premises, which is very good. You learn about IP, subnet, Cisco, Arista, the big players in the game, which can do on-premises deployment. But at some point, if you face a customer who want to connect his on-premises to the cloud, that's where the problem will come in. You need to know what is VPC. How can I extend maybe VXLAN from the cloud all the way to the customer premises? Is it private or public? So your path at that point would be cloud practitioner, solution architect associate, and then you jump to the networking part, the advanced networking specialty. where you will see more info on networking. You learn about some advanced networking concepts like VXLAN, BGP, EVPN, and so on. So maybe right now it's not stepping into what you're doing on a daily basis, but you have to be ready. Because at some point, customers would host their services on the cloud. And whether you are working in a system integrator or you're working on a CSP or you're just working on an on-premises, eventually it's going to get there and you will have a use case for that.
Thank you, Nadir. So we have another question from Salim saying, concerning the security issue, how safe is it to go for AWS? As we know, data is very critical and we should protect our clients' sensitive data.
That's a good question that we usually get, right? So first of all, when you are going to use AWS, you have control over the regions. Let's put it this way. So you are, or you can choose a region which in the same country as your customer. That's one. Two, all the data that is sent back and forth between AWS and the on-premises, it can be encrypted. You can even encrypt it with your own keys if you want. That is if you're using the internet. If you're really concerned about security, then you can go ahead and use the direct connect option to have a private lease line, right, between the data center and on-premises. On top of that, you can create something called compliance rules on AWS, where you can say that any data that comes in and out of my region must be encrypted with this protocol. It must be kept at least for 30 days. Any sensitive data should not be in my cloud environment. It should be only be on premises. So AWS can reject this data when you're trying to send it or receive it. So we do have now some customers who are preferring, especially for governments, something called cloud sovereignty. And cloud sovereignty is a concept related to how do I make sure that the data is local? How do I make sure that there are policy actually being in place and making sure that the data is encrypted? How I make sure that the data remains in my country? And how this cloud sovereignty comes out, and the cloud environment would go and do it, or cloud providers. A very nice example here in the UAE, there is a company which is actually what they did at the back end is they went to the Cybersecurity Council within the country and they said, what is your regulations if you want us to put the data on the cloud? And then they came out with a list. They said, okay, those are the 50 policies that any government in the UAE must follow if they want to put the data on the cloud. And because now this is set by the, let's say, Cybersecurity Council of the country, those policies will contain the most important info, such as what kind of encryption should we use, how long the data should be kept there, where the data should be located, right? And if we follow those agreements, we then make sure that the data is secure. So it's not just your job, you're also being backed up by many agreements and compliance based on the country where the customer is located. And that's how we convince the customer that, hey, listen, this is what the Cybersecurity Council in your country is saying. That's what we are going to follow. I'm going to show you this in a compliance and in a dashboard on AWS. And that gives him kind of, you know, the right level of confidence of going to the cloud, making sure that the governments of the country itself have set the right rules and have set the bar on what should be followed and what should not be. So I highly recommend is based on where you are, right? Look for the agreements that was done by your country. And those agreements, probably AWS, they have generated something. They have generated a paper, which is a group of config or a group of policies that you have to follow because you are hosting your data in that country. Hopefully that makes sense.
Thank you for answering that, Nadir. Does anyone else have any more questions? I think that is it for our Q&A session.
Very well. With that, guys, I would like to thank you very much for attending, and hopefully we can see you in the upcoming webinars or on one of the training sessions that we'll be doing by Formatech. With that, I would like to thank you very much, and I do hope the session has been informative for you. Have a good day.
Thank you, everyone. And I will be sharing the presentations as promised with everyone within the next few days. And as I said earlier, you'll be able to find the video of this webinar on YouTube next week. Have a great day, everyone, and thank you for joining.